So, in vertex form, you're going to rearrange the equation similar to completing the square, and it's going to be in a form that enables you to see the vertex, the maxima, the minima, the point on that graph, which is usually symmetrical about the roots, but sometimes you might have an equation that doesn't have roots, and so vertex form still enables you to get a pretty good picture of what that quadratic looks like. So the first thing you have to do with this is get rid of that coefficient, or factor it out, so that you've got single x squared. What you want there is just 1x squared. So divide by the number in front of x, and you'll have to do that to every term in the expression, and you've got x squared. Divide 12x by minus 3, you got minus 4x. Divide 36 by minus 3, you got minus 12. Once that's done, you can start working on this part of the equation. Just like completing the square, you are going to put this in a set of brackets, which is going to enable you, in completing the square, to isolate x, and in vertex form, enable you to identify a minima or a maxima. So, just like completing the square, you take the square root of this term, square root of x squared gives you x. You take half of this coefficient, so half of minus 4 is minus 2. As a side note, when you do the expansion, you'll notice what happens is you get an extra 4. So here, you expand this, right, problem, got an extra 4, need to balance that out. If I'm going to rewrite this as this, then I need to balance this by subtracting a 4. So, yes, I can rewrite that as this, if I balance it with a negative 4. So, you simplify that, and you end up with minus 16 now on this constant. So, you've isolated your x. You've now just got to multiply the 3 back out by those two main terms of the expression. So minus 3 times this, we'll just give you the same thing. But when you come to do minus 3 times the minus 16, you get plus 48. Now, that's now in the vertex form, where this number here, or rather x minus 2, gives you a vertex of plus 2, because it's plus 2 that'll bring that bracket to 0, and the constant here is just the y value of your vertex. So there's your x value of your vertex, there's your y value of your vertex. It's a vertex of 2, 48, and you can tell by the coefficient of the quadratic here. You're looking at an upside down quadratic there. It opens downwards.